Hamamuddin, am I audible?
Yes, sir.
Okay, how many questions have you solved here?
I've done till 4, sir. 5 and 6 remain.
Please do this fifth. And sixth, you need to do only the first part. The rest two part you will write and do it from home.
Okay, sir.
Okay. Will you be able to solve this? It's easy, right?
Yes, sir, I'm able to solve.
So you are going to direct solve the sixth of C part, not A part, because C is different from that. Only C part you are going to directly solve, so that if any doubts will be there, I'll be explaining this. Oh, it is gram. Any answer for the C part?
No, sir, wait. Fifth one I'm doing.
Fifth one. Are you solving the fifth one?
Yes, sir.
Just let me know the answer of fifth one.
Fifth one, sir, I'm not getting a proper answer. I'm getting 5.55 divided by 5.8.
Okay, let me see. 10% weight by weight. That means 10 gram of NaOH. in 100 gram of solution, right?
Yes, sir.
But here you can see aqueous solution. That means solvent is your water. Solvent is water. Now you can see this is your mass of solute and this is your mass of solvent. So mass of this is mass of solution. So mass of solvent, that means mass of water will be 100 minus 10, that will be 90 gram. Yes or no?
Oh, yes, sir. Yes.
If you want to calculate the mole fraction of H2O, then it will be number of moles of water upon number of moles of water plus number of moles of NaOH, sodium hydroxide. Now you can see, you can easily calculate the number of moles of water. Given mass, that is 90 gram upon molar mass 18, so you will get 5. And number of moles of NaOH, that means given mass 10 gram upon molar mass is 40, you will be getting 1 by 4. So you are going to put the value here, 5 upon 5 plus 1 by 4. Then you will be getting 5 upon, you are going to get the LCM 4 and 20 plus 1 will be here and it will be 20 upon 21. This is your answer. This will go in numerator, 5 into 4, 20 and 20 plus 1, 21. Is that clear?
Yes, sir. It's clear.
Okay, so the rest part, the sixth question you are going to get from home. This is your homework. Can I change the slide?
1 minute.
Okay, take your time.
Yes, sir. You can.
We have only two concentration term left. Can you see the screen? A new screen?
Yes, sir. Yes.
Okay. The next concentration term, before the next concentration term, there is another molarity. There is another type of question on molarity, and that is molarity of ions. We didn't discuss about this molarity of ions. Now, as you can see, this is your molarity of ions, and we are going to solve it with the help of an example. I'm going to explain this with the help of a question, and that is, I'm going to take a very easy question. 49 gram of H2SO4 presenting 500 centimeter cube of solution calculate molarity of the first one, H2SO4. You need to calculate the molarity of H2SO4. That is basic. The way we did calculate the molarity of the solution or calculate the molarity of this solution present in H2SO4. The B is calculate the molarity of H plus, which is ion. I'm going to explain this, and SO4 minus 2. So first, you are going to tell me what will be the molarity of H2SO4, and you can do it easily.
Okay.
First, you are going to solve it. Just let me know. It's very simple. Have you got the answer?
Yes, sir. 1 minute.
Okay, I'm going to explain. Molarity is equal to number of moles of solute upon volume of solution in liter. Now you can see volume is given, that is 500 upon in liter. So we have to divide it by 1000, right?
Yes, sir.
And here number of moles of solute you can easily calculate, and solute is your H2SO4. Given mass 49 and molar mass that is 98. So you will be getting 1 by 2 mole. So you are going to write 1 by 2 mole, and this will also be cancelled by 1 by 2. So the answer that you will get is 1 molarity. Yes or no?
Yes, sir.
Have you got the same answer?
No, sir.
Where you have mistaken. That is very important for me to know where you have mistaken.
Calculation for 500 divided by 1000. There, I took time.
Oh, so be careful while calculating. If you know the concept, then even you don't get your full marks
Okay, sir.
only because of this calculation. So please be careful about that. Now see, this is the basic calculation of molarity. Now to calculate the molarity of the ions, you need to dissociate this H2SO4 into ions. You know, H2SO4 will be dissociated into this H plus and SO4 minus 2. Now you need to also balance this. As you can see, 2 hydrogen on the left hand side. So I'm going to multiply it by 2. Now it is balanced, right? Yes or no?
Yes, sir.
Now you can see it is balanced. Atom is also balanced. Charge is also balanced. If you are going to check charge on the left hand side, it is 0 because there is no charge that you can see. But on the right hand side, you can see one hydrogen has plus 1 charge. So 2 hydrogen has plus 2 charge. One SO4 has minus 2 charge. So overall charge on the right hand side is also 0. So charge is also balanced as well as atoms are also balanced. Now come to this. We are going to compare this moles. It's mole. You can see what is the stoichiometric coefficient? 1. The stoichiometric coefficient is just like the coefficient in maths. You know that this is your x square. What is the coefficient of x square? 1. This is your x, 2x cube. What is the stoichiometric coefficient of x cube? That is 2. Are you getting my point? So if
Yes,
I'm going
sir.
to ask you, what is the S2? In chemistry, we use the term stoichiometric coefficient. What is the stoichiometric coefficient of H2SO4? That is 1. What is the stoichiometric coefficient of H plus? That is 2. And what is the stoichiometric coefficient of SO4 minus 2? Can you tell me?
1.
1. Now you are going to relate this in terms of mole and molarity. 1 mole of H2SO4 will give you 2 mole of H plus and 1 mole of SO4 minus 2. Is that clear? This concept you have studied in class 11, stoichiometric, first chapter. Is that clear?
Yes, sir.
Now you are again going to combine this in terms of molarity. One molarity of this will give you 2 molarity of this and 1 molarity of this. Are you getting my point? With the help
Yes.
of the stoichiometric, I am defining. Now go for the molarity that you have calculated for H2SO4. You can see how many, what is the molarity of H2SO4? 1m. Actually, it was 1m. So 1m, if 1m is this, so it will be 2m and this will be your 1m again. So molarity of H plus will be 2m and molarity of SO4 minus 2 will be 1m. Are you getting my point?
Yes, sir.
If you will have the molarity of H2SO4 2m, so you are going to write the, you can see 1 will give 2. So 2 will give 4m. Are you getting my point? 1 will give 1. So 2 will give 2 molarity. If you will get the molarity of H2SO4 2m, then the molarity of H plus will be 4m and molarity of SO4 minus 2 will be 2m. Is that clear?
Yes,
Please
sir.
do write it. Just let me know when you are done with this.
Done, sir.
Okay. Now the next concentration term, that is molality, and it is denoted by a small m. I'm going to define this first. Number of moles of solute per unit mass of solvent in kg. This is the only concentration term in which in denominator we will have to write the value of solvent, and it should be in kg. Are you getting my point? In every concentration term you have seen that the denominator part is always solution, but this is the only concentration term in which we are going to write the value of the solvent, and it's actually mass in kg. So we can also write a formula for this. Molality will be equal to number of moles of solute, number of moles of solute upon mass of solvent in kg. Mass of solvent in kg. It's very easy. Mass of solvent in kg. And its unit, as you can see, in numerator it is moles and in denominator it is kg. So the unit will be moles per kg, or we can directly write a small m in the way we did for molarity. Are you getting my point?
Yes, sir.
Okay, so please do write it. Then I'm going to give you a question on this, and I think you can easily solve this.
Done, sir.
Okay. Now, 10 gram of CaCO3 presenting 90 gram of water. Calculate molality. I think you can do this. Please do it. Let me know if you're facing any kind of problem.
Yes, sir. 1.1.
Let me just check it. So as you can see, mass of solute is given and mass of solvent is also given. So for molality, you know the formula, number of moles of solute upon mass of solvent in kg. So number of moles of solute here is CaCO3. So it has given mass and the molar mass is 100. So it will be 1 by 10 moles. Now, mass of solvent is also given. So 1 by 10, mass of solvent is 90 gram. You have to convert it into kg. So divided by 1000. And you can see you will get 1 by 10 upon 9 by 10. So this will be written as 1 by 10 into 10 by 9. So 10 and 10 will be cancelled and you will be getting 1 by 9 m. So it is 0.11 moles per kg. Where you have mistaken?
1 minute, sir.
Just check it and let me know.
Yes, sir. I took 9 by 100 instead of 90 by 100.
Oh, wait a minute. You are right. You are right. I'm wrong here. Sorry. You are right. Just wait a minute. Sorry, I just did it miss. I got it wrong. 90 upon 1000. So 9. Only 10 will be cancelled now. So it will be 1 by 10 upon 100. Let me check it again. 1 by 10 into 100 by 9. So it will be like, you are right. Thank you. I'm sorry I did it. So this will be your answer. Good. Now I'm going to give you another type of this, which is 10% weight by weight NaOH in aqueous solution. Calculate molality. Are you done with this?
Yes, 5 by 2.
Just let me check it. It will be 10 upon 40 upon 90 by 1000. This is the equation that you have got, yes or no?
No, sir. 90 by we should take.
Wait a minute. Molality is equal to number of moles of solute upon mass of solvent in kg, right?
Yes, sir.
This is the mass of solvent. What is the mass of solvent that you have got?
Oh, sorry, mistake. I took 100 instead of 90.
Okay, just take care of it.
25/9.
Okay, number of moles you can see this and this will be cancelled, this will be cancelled, and this will be cancelled by 25. So the answer is 25/9, right?
Yes, sir.
Now the last concentration term is here, that is normality. Normality is n. See, first of all, I'm going to define number of gram equivalent of solute. Wait a minute, I'm going to write it full. Number of gram equivalent of solute per unit volume of solution in liter. Normality and molarity is almost same, but only the difference here lies here. The difference lies here. As you can see, in molarity, there was volume of solution term in denominator, and in numerator, there was number of moles of solute. But when you are going to watch this, you can see it is number of gram equivalent. And what is this? So before starting this normality term, I'm just going to write the formula here first, and then I'll explain. So normality can have an expression or mathematical equation. Normality n is equal to number of gram equivalent of solute upon volume of solution in liter. So the unit of this normality will be gram equivalent per liter, or either we can directly write n. So this is a basic formula of normality, which is very easy. You can see it's very easy. Please do write it first. First, you are going to write it, and then I will start this.
Done, sir.
Okay, see. So to understand normality, we have to first look at what is gram equivalent or number of gram equivalent. And to understand this quantity, we have to first deal with equivalent mass or equivalent. Either you can call it weight, or either you can call it mass. Okay. Now see. So first we are going to deal with this equivalent weight or equivalent mass. So, and then we are going, I will explain this and this. Today we are going to cover this part. So as you can see, equivalent mass or equivalent weight has a formula, that is molarity, molar mass upon X. You can calculate the molar mass of any compound, that is given, right? Yes or no?
Yes, sir.
And here the X is known as valence factor, or either it is N factor. So how do we know what is X and how we are going to calculate it? It's very easy. I'm going to explain this. First, you are going to write it.
Done, sir.
Done. Wait a minute. Now see how we are going to. Actually, I was looking at the notification after this class is going to over at 7:30, around 7:30. So you will be getting a test paper for half an hour, and there is only. Just wait a minute. There is one, two, three question is there. No, not three. 1, 2, 3, 4, 5. 5 question is there. And you can solve that. Okay.
Okay, sir.
Now see, this x, we are going to first divide it for 3 categories. You can easily understand or recognize whether which one is acid, which one is base, and which one is salt, right? Acid base salt, you can recognize it. Like if I'm going to write it HCl, what is this? This is your acid. NaOH, what it is? This is your base. NaCl, what it is? It is salt, right?
Yes, sir.
So if it is an acid, then the value of X is equal to number of H plus given. Then the value of H, then the value of X will be equal to number of H plus given. You know that HCl will give only one H plus. So if you are going to calculate the equivalent weight of this HCl, it will be molar mass of HCl that you can easily calculate upon the number of H plus given by HCl, that is 1. So molar mass upon 1. That means 36.5 by 1 is the equivalent weight of HCl. Is that clear?
Yes, sir. It's clear.
Now, if I'm going to write, calculate the equivalent weight of H2SO4. Can you tell me the value of X now?
For H2O, NaOH, right?
No. First, you need to see it carefully. H2SO4 is an acid, base, or salt. It is an acid, right?
Yes.
Now, can you tell me how many H plus this H2SO4 will give you? How many H plus ion will be given by this H2SO4?
2H plus.
2H plus. That means how many H plus? 2. So that's why the value of X or N factor or valence factor for this H2SO4 will be equal to 2. Are you getting my point? So it
Yes,
will
sir.
be mm by 2. So 98 by 2, that means 49 is the equivalent weight of H2SO4. Are you getting my point?
Yes, sir. Got it.
Now, can you tell me the equivalent weight of HNO3? You need to calculate the equivalent weight of HNO3. Just let me know.
So 63.
Yeah, 63 is the molar mass, and it will give only one H plus, so that's why it is 63 is the equivalent weight of HNO3, right?
Yes.
In the same way, if it is base, then X, that means valence factor or N factor, will be equal to number of OH minus given, number of hydroxide given, or number of OH minus given. Now, can you tell me the equivalent weight of NaOH?
40.
40. Very good. 40 upon 1, it will be 40. Now, if it is MgOH whole twice, you can see it is whole twice. That means it will give 2 OH minus. So the value of X is equal to 2. And if you are going to calculate the equivalent weight, it will be molar mass upon X, that is 2. And you can easily calculate the molar mass of MgOH whole twice, right?
Yes, sir.
Now, if you are going for salt, X is equal to either total positive charge, or either it will be total negative charge. You don't need to take it with sign. You just need to take the magnitude, take the number. Either you are going to take total positive charge, either you are going to take total negative charge. Now, if NaCl is there, how you are going to get the positive or negative? So if you are going to dissociate it, it will be dissociated into Na plus and Cl minus. So equivalent weight will be equal to molar mass of NaCl that you can easily calculate. And either you can calculate, take +1 or -1, you are going to take the number only. Okay, actually this salt will have equal positive or negative charge. So you can either take positive or negative, that will be same. Are you getting my point? You just
Yes,
need
I
to
got it.
dissociate it and get it. Now you can see CaCO3 is there. So if you are going to dissociate it, calcium will go in +2 and carbonate will go in -2. So if you are going to calculate the equivalent weight, you know the molar mass of CaCO3, that is 100, and either you can take this or this, they both will be similar. This equation must be balanced, then you will get only. So it will be 50, right? Equivalent. So this is how we calculate equivalent weight. Okay, so
Okay, sir.
please do write it. Are you done with this?
1 minute, sir.
Okay, take your time. We will be continuing from here. I'm here.